Beneath the blazing sun, one tiny planet hides enormous secrets: Mercury. Small, hot, and full of surprises, this planet has baffled scientists for years. But now, space exploration has begun to peel back the mysteries, revealing shocking discoveries. Did you know that diamonds might exist on the hottest planet in the solar system? And that's just the beginning. Mercury's core is unexpectedly large, and its internal structure is unlike anything we've seen before. What makes Mercury so unique, and what other secrets could it be hiding? Before we dive deeper, don't forget to like this video and subscribe to our channel. By subscribing, you won't miss out on the latest mind-blowing discoveries from the far reaches of space. Mercury, the smallest planet in our solar system, has long been a subject of fascination. For centuries, its surface was hidden from view, but that all changed with the advances in space technology. NASA's Mariner 10 mission in 1973 was the first to give us a close-up look at Mercury, followed by the Messenger mission in 2004, which provided even more groundbreaking insights. Mariner 10 flew by Mercury and showed us a world scarred by craters and ridges, much like our moon. It revealed a planet with a surprisingly strong magnetic field and a core much larger than expected, challenging many assumptions about how the planet formed. But it was Messenger, which orbited Mercury starting in 2011, that truly transformed our understanding. Over its mission, Messenger captured over 200,000 images, revealing parts of the planet never seen before. One of Messenger's most intriguing findings was the detection of high levels of calcium and magnesium on the planet's darker side, sparking questions about how these elements ended up in such concentrations. Even more surprising was the discovery that Mercury's magnetic field is much stronger in its northern hemisphere, unlike any other planet we've studied. What really sets Mercury apart, though, is its extreme environment. Temperatures on the planet can reach up to 430 degrees Celsius, 806 degrees Fahrenheit, during the day, hot enough to melt lead, while plummeting to a frigid -180 degrees Celsius, -292 degrees Fahrenheit, at night. This incredible temperature swing is due to Mercury's lack of a thick atmosphere, leaving it unable to retain heat. Despite these harsh conditions, Mercury isn't as lifeless as once believed. In 2012, scientists found evidence of volcanic activity on the planet's surface, indicating that it might not be geologically dead after all. Even more astonishing, in 2020, water ice was discovered in Mercury's polar craters. These regions, permanently shadowed from the sun, are cold enough to preserve ice, a remarkable find for a planet so close to our star. Could this ice be hiding simple forms of life, perhaps similar to extremophiles found in Earth's harshest environments? Looking ahead, the Bepi-Colombo mission, launched in 2018 by the European Space Agency and the Japan Aerospace Exploration Agency, is expected to reach Mercury in 2025. This mission aims to provide even more detailed information about the planet's surface, its mysterious magnetic field, and the presence of water ice. But here's something that might really blow your mind: on Mercury, a year is shorter than a day. That's right, it takes Mercury only 88 Earth days to orbit the Sun, but a single day on the planet lasts 176 Earth days. This means that Mercury has just half as many days as it does years. And if you stood on the planet's surface, you'd witness one of the strangest sunsets in the solar system. The sun would appear to rise, stop, move backward, and then continue forward again. This bizarre phenomenon occurs because Mercury's rotation is so slow compared to its orbit, a result of the sun's gravitational pull slowing the planet down over billions of years. This slow rotation, known as tidal locking, keeps Mercury in a unique 3-to-2 spin orbit resonance, meaning it rotates 3 times for every 2 orbits around the sun. This also contributes to the planet's extreme temperatures, as one side faces the sun for months at a time, baking under the intense heat, while the other side remains in freezing darkness for equally long periods. Mercury's atmosphere, or rather its lack of one, is equally unusual. Instead of a thick, protective atmosphere like Earth's, Mercury has a thin exosphere made up of gases that are constantly being stripped away into space. Solar winds, radioactive decay, and micrometeorite impacts continuously replenish this thin layer, but it never forms a stable atmosphere. As we continue to explore Mercury, new questions keep emerging. What else could this planet be hiding, and how does it manage to survive so close to the sun's fierce heat? The more we discover, the stranger and more fascinating Mercury becomes. Stay tuned, because the secrets of this tiny planet are far from fully revealed. When hydrogen from the solar wind combines with oxygen in Mercury's surface rocks, it creates fascinating chemical interactions on the planet. Another intriguing aspect of Mercury is how its short year and long day affect its magnetic field. Despite its small size and slow rotation, Mercury has a global magnetic field, which surprised scientists when it was first discovered. Recent research suggests that this magnetic field is generated by a unique dynamo effect in its liquid metal core, driven by the planet's unusual orbit and rotation. While much weaker than Earth's magnetic field, it still plays a crucial role in protecting Mercury's surface from the harsh solar wind. Without it, Mercury's already thin atmosphere would be stripped away even faster. Either way, if you're finding this information fascinating, make sure to hit the like button and subscribe to stay updated on more incredible space discoveries. You don't want to miss out on the latest news about Mercury and other planets in our solar system. Mercury's rapid orbit and slow rotation also make for some interesting observational opportunities. There are specific points on Mercury's surface, known as hot poles, where the sun appears to stand still in the sky, subjecting those areas to extreme heat. On the other hand, areas near Mercury's poles never see sunlight, and it is in these permanently shadowed regions where scientists have found evidence of water ice. This discovery is surprising given Mercury's proximity to the Sun, but the deep, shadowed craters remain cold enough to preserve ice. The Bepi-Colombo mission, currently en route to Mercury, is taking on the challenging task of studying the planet up close. Launched in 2018, this spacecraft is using a series of complex flybys of Venus and Mercury to slow down and enter orbit around the planet by 2025. Once there, it will face the difficulty of operating in Mercury's extreme environment, balancing intense daytime heat with the long, cold nights. Scientists are still piecing together how Mercury ended up with its unique rotation rate. Current models suggest that the planet may have rotated much faster in the past, only to be slowed down by the Sun's gravitational pull and impacts from asteroids. This insight not only deepens our understanding of Mercury but may also offer clues about the history of other planets in the solar system. One of Mercury's most puzzling features is its large core, which takes up about 85% of the planet's volume. This is much larger compared to Earth's core, which makes up only 15% of our planet's volume. Scientists believe this might be due to a hit-and-run collision with another body early in the solar system's history, stripping Mercury of much of its outer layers and leaving behind the dense core we see today. In addition, Mercury's magnetic field is highly unusual. It is not only much weaker than Earth's, but it is also offset from the planet's center by about 20% of its radius. Scientists think this could be due to irregularities in the planet's crust, which affect how heat escapes from the interior. In recent years, researchers have made several surprising discoveries on Mercury. Volatile elements like sulfur and potassium have been found on its surface, elements that should have evaporated at such high temperatures. Scientists speculate these might have been delivered by comets or asteroids. Mercury also shows signs of past volcanic activity. What was once thought to be a geologically dead world now shows evidence of recent volcanic eruptions, as indicated by small volcanic vents and bright spots on the surface. This means Mercury might still be geologically active today. Despite being the smallest planet in our solar system, Mercury continues to reveal new mysteries. Scientists are still debating how its core remains partially liquid, how its orbit influences its geology, and whether it holds clues to the origins of life through the presence of organic compounds in its icy craters. These unique characteristics challenge our understanding of planetary evolution and leave us wondering what other secrets Mercury may be hiding beneath its cratered surface. The Smithsonian Institution suggests that Mercury's terrain may have been shaped by massive earthquakes caused by the Sun's tidal forces as its orbit evolved. Recent research has also revealed key insights into Mercury's composition. Dr. Amir Khan from the University of Zurich, using data from NASA's MESSENGER mission, discovered that Mercury's core has a liquid outer layer and a solid inner core. This core is much larger than Earth's in proportion and may explain Mercury's unusual magnetic properties. These discoveries challenge our understanding of planetary formation. They remind us that even in our own solar system, mysteries remain. Future missions may uncover even more secrets hidden beneath Mercury's surface. One of Mercury's most intriguing features is its core structure, which differs from Earth's, being mostly liquid. The planet's thin mantle and evidence of volcanic activity suggest complex geological processes. In 2020, researchers found evidence of a long-lost magma ocean, which likely shaped the planet's surface. Another surprise came in 2022, with the discovery of nitrogen beneath Mercury's surface, hinting at a possible ancient atmosphere. Mercury's polar craters also hide water ice, likely delivered by comets or asteroids, as well as organic compounds, which provide a unique opportunity to study the inner solar system. Mercury's tectonic history is also intriguing, with evidence that the planet may still be geologically active. Additionally, scientists speculate that subsurface fractures might allow heat and even liquids to move through the crust, possibly containing pockets of water deep underground. As we learn more about Mercury, new questions arise about its evolution and what its hidden depths can reveal about the history of our solar system. Exciting stuff, right? What do you think we'll discover on Mercury next? Valuable minerals? Signs of life? If you enjoyed this video, hit the like button and subscribe to stay updated. Thanks for watching.